Hello, my name is Shaun Scallan, and I'm here to share with you a vision of waste reimagined. At Capricorn Power, we believe there is no such thing as waste, only resources we haven't yet been clever enough to use fully. Nature is clever and has worked out that there are only resources that endlessly cycle. We also believe it is our duty to connect our activities into natural and sustainable cycles. By doing so, we can not just minimise waste, but restore our much damaged ecosystem. Indeed, making the world a better place through reimagining waste. Our mission, therefore, is transforming waste into resources. And to do that, we're developing a number of innovative solutions for transforming heat and biomass waste into sustainable resources. Let's begin. Heat is used to create electricity at large scale with moderate efficiency. Heat is also used in many processes for tasks such as melting, drying, treating, cooking, or otherwise processing raw materials during the manufacturing processes. But did you know that 72% of this process heat is lost globally? This is a wasted resource quite clearly. So let's talk about the ways we get electricity from heat. The most common one is using a steam Rankine cycle. So water is heated into steam, it's put through turbines, and these turbines spin a generator which provides you and I with electricity. The graph here shows the efficiency of the steam Rankine cycle for various configurations, and there are many, over the temperature range in which it would operate. So efficiencies ranging from 20 up to, there's an outlier at 50 there, 20 to 50%. So that's the theoretical efficiencies of those processes. So this technology is efficient and cost effective at large scale, but cannot scale down. There are small but inefficient generators of electricity from heat, and they use a Rankine cycle as well, but use a different working fluid. It's a refrigerant that's an organic chemical of some type that's effective in this cycle. So it is small, but it is inefficient. Wouldn't it be better if we had a small and more efficient heat engine? We could recover more energy, and that has got to be a good thing. Well, this is what we have done, and are continuing to work on commercialising the next version of our innovative heat engine. And this heat engine uses a variation on the recuperated Barton Cycle, which is called the Barton Cycle. This Barton Cycle is named after one of our founders and CTO, Dr. Noel Barton, AM. Noel left a successful career at CSIRO around 15 years ago to work on heat engines, and a little over 3 years ago he helped found Capricorn Power. Noel is passionate about doing something positive for the world, and he is responsible for the underlying mathematical modelling of this patent pending process innovation, this digital twin, if you will. From the graph you can see the contrast in efficiencies over temperature ranges. So here is our core innovation. It is an efficient small-scale heat engine in a container. It's plug and play. You plug in the heat on the left and you get electricity out on the right. It's quite simple. So what's in the box? What's the secret sauce? Well, it is our patent pending technology, which is a process innovation that turns the waste heat into electricity at an efficiency that is significantly better than current competitors. So it's waste to energy, it uses no water, it has zero emissions, it's on-demand power, and by that I mean that you can dispatch it or schedule it to run to produce energy, which is important to support the grid, which has lots of variable renewable energy in it. And this is like a baseload energy generation source, if you like. So we think of it as sustainable energy from a number of perspectives, and it has less than 1% of the footprint of equivalent PV array in terms of area for an equivalent rating. So all in all, it's quite a nice, tidy package. As I've said, it's plug and play, heat in one end, electricity out the other end. So minimum disruption to site. We just tap into the heat source and take the electricity out the other end. Our process innovation extends to using proven technology that is low risk and easier to scale. It means we don't need a large R&D team, and so we have short time to market. So it's proven technology, lowers delivery risk and accelerates time to market. And our current plan, our Mark II engine, is scheduled to be operational by the end of this calendar year. So what's the link to biochar? How does it relate? I am reliably informed by colleagues in the industry that there is some heat available when making biochar. Waste heat. Heat we can create value from using our heat engine. Here you see our Mark I engine from 2018, taking waste heat from a crematorium. The pipe on the left takes exhaust heat from the flue and pipes it into our heat engine. So where else could we get heat from? Could we convert other biomass into heat and at the same time generate electricity and produce a carbon capture and storage solution that actually works? The answer is yes. One answer is pyrolysis, a well understood thermochemical process that, coupled with a more efficient heat engine, can make for a compelling business case. So, how do we approach this and visualise this bioenergy power station? Here is our business model. We have a turnkey integrated bioenergy power station that takes biomass from the left-hand side. It pyrolyses that to create biochar, and the heat that goes forward goes through to the heat engine where electricity is generated, and by definition that is bioenergy. We think the Barton heat engine is a good match for sites with organic waste which can be pyrolysed, and so we can generate some baseload power from that heat, so scheduled generation as opposed to variable generation, which most renewables are. So let's look at some numbers. If you had 5,000 tonnes per annum of biomass, you could produce around 1,250 tonnes per annum of biochar and around 3,000 megawatt hours of electricity per year, which is enough to power over 400 houses. So quite a bit of energy. And that also leaves some heat left over to help dry the incoming biomass to make the pyrolysis more effective. Biomass produces bioenergy and biochar. Lots of bio words there. Bioenergy is from a renewable source and so reduces our usage on fossil fuels. Biochar can be used to restore our soils and ecosystems and builds our natural capital, as you well know. Biochar connects us with the natural cycles of the biosphere. Biochar is carbon negative but planetarily positive. Our goal is to accelerate a transition to the circular economy where waste as a word loses its place and its meaning through integrated bioenergy projects. our process for delivering value. It all starts with the assessment of the biomass, looking at the opportunity from the outputs of that biomass, building a business case and feasibility, and then proposing projects to deliver that. That's our end-to-end process. Pretty straightforward, really. And what of the future? At the same time we're commercialising our heat engine, we are conducting 3 feasibility studies using 3 different types of biomass, pyrolysis, and the Capricorn Power Barton Cycle heat engine. We think we can make these projects stack up for a sub 3-year payback with a number of assumptions, including a market for biochar providing the necessary value stream that we need to make the project viable. We also believe there is a pathway to even higher value products being produced, further strengthening the value proposition. There are many opportunities in the bioenergy space, and today we have touched on one possibility. In order to make this work, we must address the key elements of any business case. These include securing the value streams through offtake agreements, as well as targeting the likely early adopters. We have chosen councils and wood processors initially, and there will be many other possibilities, of course. In the longer term, there are opportunities to add further value to biochar. For example, and it's only an example, the conversion to activated carbon. The times do seem to support bioenergy. The country's Renewable Energy Agency has been tasked with delivering a bioenergy roadmap to the federal government later in 2020. Australia's energy mix is only 4% bioenergy, compared to an OECD average of around 7%. Clearly, we've got some opportunities to increase that. I'd like to conclude with a summary of the benefits of the combination of pyrolysis with the Barton heat engine. These include waste disposal, rising energy costs can be combated, more renewable energy is required on the grid. This renewable energy is bioenergy and can be dispatchable, which is a real benefit in balancing the variable renewable energy we have on the grid. And this is not to forget the numerous benefits of biochar. As a tool for restorative agriculture, we can use it to rebuild our natural capital in a truly sustainable way. I like to think of it as restoring the garden. These are early days in this journey, and we are looking forward to working with the biochar industry to help catalyse biochar and energy projects to build a better place for all who live here. Thank you for listening. We look forward to your questions.